Welcome to the quantum world. Today we embark on an incredible journey into the realm of quantum mechanics, a field that defies our everyday understanding of reality. Imagine a place where particles can exist in multiple states at once, and where the very act of observing something can change its behavior. This is the quantum world, a place full of wonder and mystery. Did you know that an electron can be in two places at once? This phenomenon is known as superposition, and it's one of the many mind-bending principles of quantum mechanics. In the classical world, an object can only be in one place at a time. But in the quantum world, particles like electrons can exist in multiple locations simultaneously, as if they are spread out like a wave. That's the strange and fascinating world of quantum mechanics. Particles behave in ways that seem completely counterintuitive. They can tunnel through barriers, entangle with each other across vast distances, and exhibit behaviors that challenge our understanding of cause and effect. It's a world where the rules of classical physics no longer apply, and new bizarre rules take over. It's like a secret code that governs how tiny particles behave. Scientists use complex mathematical equations to describe these behaviors, and these equations often predict outcomes that seem impossible. Yet, experiments have repeatedly confirmed these predictions, showing that the quantum world operates on principles that are fundamentally different from those of the macroscopic world we experience every day. In this essay, we'll journey together to understand this mind-boggling subject in simple terms. We'll explore the key concepts of quantum mechanics, such as wave-particle duality, quantum entanglement, and the uncertainty principle. We'll also look at how these principles are being applied in cutting-edge technologies like quantum computing and quantum cryptography. Get ready for a wild ride. The quantum world is full of surprises and paradoxes that will challenge your perception of reality. But don't worry, we'll guide you through each concept step by step, making sure you understand the basics before diving into the more complex ideas. Imagine a world where the rules of our everyday life don't apply. In the quantum realm, particles can behave like waves, and waves can behave like particles. This duality is one of the core principles of quantum mechanics and leads to some truly astonishing phenomena. Objects can be in multiple states simultaneously. This is not just a theoretical concept, it's been demonstrated in countless experiments. For example, in the famous double-slit experiment, particles like electrons create an interference pattern that suggests they are passing through multiple slits at the same time. Information can travel instantly across vast distances. This phenomenon, known as quantum entanglement, has been described by Einstein as spooky action at a distance. When two particles become entangled, the state of one particle instantly influences the state of the other, no matter how far apart they are. This has profound implications for communication and computing. This is the realm of quantum mechanics, a branch of physics that studies the very building blocks of our universe. From the tiniest particles to the vastness of space, quantum mechanics provides a framework for understanding the fundamental nature of reality. It's a field that continues to evolve, with new discoveries and applications emerging all the time. Don't worry, we'll break down these complex concepts into bite-sized pieces you can easily digest. Let's begin. Together, we'll unravel the mysteries of the quantum world and discover how this fascinating field is shaping the future of science and technology. The Quantum Mechanics Playbook. In the world of big things like cars and cricket balls, we use classical physics. This branch of physics, developed by giants like Newton and Galileo, provides us with a set of rules that are intuitive and easy to understand. These rules help us predict the motion of planets, the trajectory of a cricket ball, and even the way cars move on a highway. Classical physics is all about certainty and predictability. It's like a rule book that describes how things move and interact. Imagine it as a comprehensive guide that leaves no room for ambiguity. Every action has a reaction. Every force has an equal and opposite force, and everything follows a predictable path. This rulebook has served us well for centuries, allowing us to build bridges, launch rockets, and understand the mechanics of everyday life. But when we zoom into the microscopic world of atoms and electrons, classical physics fails. The rules that govern the macroscopic world no longer apply. At this scale, particles behave in ways that are completely counterintuitive. They can be in multiple places at once, and their properties can change just by being observed. This is a realm where the old rulebook is thrown out the window. We need a new set of rules. That's where quantum mechanics comes in. Quantum mechanics is the branch of physics that deals with the behavior of particles at the atomic and subatomic levels. It introduces concepts that are so strange and fascinating that they challenge our very understanding of reality. These new rules are not just theoretical. They have practical applications in technologies like semiconductors, lasers, and even quantum computers. Think of it this way. In classical physics, a coin toss has a definite outcome, heads or tails. You can predict the result if you know the initial conditions like the force of the toss and the air resistance. It's a straightforward process where cause and effect are clearly linked. This is the world of certainty that classical physics describes. But in the quantum world, the coin can be both heads and tails at the same time until we observe it. This phenomenon is known as superposition. In this state, the coin exists in all possible outcomes simultaneously. It's only when we measure or observe the coin that it chooses a specific state. This idea is not just a theoretical curiosity, it has real-world implications for how we understand and interact with the universe. This mind-bending concept is called superposition, and forms the heart of quantum mechanics. Superposition allows particles to exist in multiple states at once, leading to phenomena like quantum entanglement and quantum tunneling. These concepts are not just academic, they are the foundation for revolutionary technologies that could change the world. Quantum mechanics opens up a universe of possibilities that are as exciting as they are perplexing. Quantum superposition, it's all about possibilities. This concept is one of the most fascinating and mind-bending aspects of quantum mechanics. It challenges our classical understanding of reality and opens up a world of endless possibilities. Superposition is like a child playing multiple roles in a school play. Imagine a scenario where a child can be both the hero and the villain at the same time, seamlessly switching between roles without any conflict. Imagine little Rahul is both a brave knight and a mischievous goblin at the same time. He embodies both characters, and only when the audience looks at him does he choose one role to play. This duality is at the heart of quantum superposition. That's what particles like electrons can do. They exist in multiple states simultaneously. In the quantum world, an electron can be in multiple places at once, spinning in different directions, or even having different energies. Now, before you start picturing electrons leading double lives, remember that this superposition collapses to a single state when we measure it. This phenomenon is known as the collapse of the wave function. It's like the electron makes a choice, just like Rahul does on stage. It's like when the curtain rises and Rahul has to choose to be either the knight or the goblin. The act of observation forces the electron to settle into one of its possible states, just as the audience's gaze compels Rahul to pick a role. This ability to exist in multiple states is what makes quantum computers so powerful. Unlike classical computers that use bits as the smallest unit of data, quantum computers use qubits. These qubits can represent both 0 and 1 simultaneously, thanks to superposition. This allows quantum computers to process a vast amount of information at once, solving complex problems much faster than traditional computers. The implications of quantum superposition extend far beyond computing. It has the potential to revolutionize fields like cryptography, material science, and even medicine. Imagine a world where we can simulate complex molecular structures to design new drugs or create materials with properties we've never seen before. The possibilities are truly endless. Understanding quantum superposition is not just for scientists in labs. It's a concept that can inspire curiosity and wonder in everyone, from students in classrooms to enthusiasts exploring the mysteries of the universe. It's a reminder that the world is full of possibilities waiting to be discovered. Quantum entanglement, spooky action at a distance. Entanglement is where things get really spooky. Imagine you have two magical coins that are linked. If one lands on heads, the other instantly turns tails, no matter how far apart they are. That's entanglement. Two particles mysteriously connected across vast distances. Albert Einstein famously called this spooky action at a distance because it seemed to defy the laws of physics as we knew them. But experiments have proven entanglement to be real, and it has mind-blowing implications for secure communication and teleportation. Yes, you read that right, teleportation. The uncertainty principle. You can't know everything. Imagine trying to take a picture of a hyperactive puppy. The more you try to pinpoint its location, the blurrier its motion becomes. That's the essence of Heisenberg's uncertainty principle. The more accurately we know a particle's position, the less we know about its momentum, and vice versa. This isn't about the limitations of our instruments, it's a fundamental principle of the universe. It's like the universe is telling us that there's a limit to how much we can know about these tiny particles. Now for the grand finale, wave-particle duality. Imagine a creature that can shapeshift into a bird or a fish depending on the situation. That's kind of what light does. Sometimes it behaves like a wave, like ripples in a pond, and sometimes like particles, like tiny balls of energy called photons. This dual nature of light is one of the most intriguing mysteries in quantum mechanics. It's like light is playing a cosmic game of hide-and-seek, never revealing its true form completely. Quantum mechanics isn't just theoretical mumbo-jumbo, it has real-world applications that are changing our lives. Lasers, used in everything from barcode scanners to eye surgery, are based on quantum principles. Then there are MRI machines that use powerful magnets and radio waves to create detailed images of our internal organs. And let's not forget the ongoing experiments with quantum teleportation, where information is transported instantly across distances, just like in science fiction. The future possibilities are truly limitless. Now, let's address some common myths surrounding quantum mechanics. Some people think it means anything is possible, like walking through walls. While it's true that quantum events are probabilistic, it doesn't mean we can defy the laws of physics. Sorry to burst your bubble. Another myth is that it's too complicated for ordinary people to understand. Sure, it's complex, but with a little effort and a lot of curiosity, anyone can grasp the basic concepts. Just like learning a new language, it just takes time and patience. Quantum mechanics is a journey into the heart of reality, a quest to understand the fundamental building blocks of the universe. As we continue to unlock its secrets, we open doors to a future filled with unimaginable possibilities. So, stay curious, keep asking questions, and who knows, maybe one day you'll be the one making groundbreaking discoveries in the quantum realm. The future is bright, the future is quantum.